Welcome back. In the previous video we discussed rational versus irrational numbers and saw that there are different types of infinity. In the video before that we saw that within an infinity you can do a lot of stuff in that Hilbert Hotel example and you're still going to be able to fit an infinite amount of stuff into an infinity. So on the one hand, if you're within an infinity it's kind of the same, but across infinities it could be very different. So with those ideas in mind, do longer segments have more points than shorter segments? So you could have sort of two different intuitions. On the one hand, obviously yes, because there's more stuff over here. But on the other hand, you might be thinking, well, there's an infinite amount of points in both of them, so maybe that's an example of those same sizes of infinity. So we're not sure what's going to win out. All right. So there's one key idea, and in this video, which is one-to-one correspondence. Now this isn't the only idea, but this is a very typical way to analyze these things. So the idea is, if we want to know which has more points, we're going to group them. So for example, let's say there's 4 dots here, 3 dots here. If we match them up, so this one-to-one correspondence, and this one has an extra point, then this one has more points because it's not counted yet. All right, so that's the very simple idea. So here's what we're going to do. Let's say you had a little flashlight and you are shining a light. Now you've positioned it in such a way such that this beam hits both of these points. All right, so now check this out, and this is at the same horizon level. As you angle this flashlight down, so let's say it's over here, you're gonna hit these 2 points. Assuming these are like see-through or something. As you change the angle, you should convince yourself that you'll hit all of these points. And anytime you hit one of these points, you're gonna hit one of those points. So for example, if you're gonna hit this point, then you're gonna hit that point. So because of this argument, although this is a longer segment, there is an equal size infinity. So the answer to this question is no, and so the answer is that they're equal because they both have an infinite amount of points, but that's not in itself good enough. But through the one-to-one correspondence, those infinities are grouped one-to-one, so that's why they are equal. Just like you have an infinite amount of odd numbers and even numbers, and you could pair 1 with 2, 3 with 4. In the same way, one of these points always pairs up with one of these. So you might think like that's not very satisfying. So yeah, the density of these is tighter, is a little smaller than those, but it's not like you're gonna say, hey, I've counted these, I've grouped them with these, but then there's a leftover point because that point will go with that point. So there's always a one-to-one thing, and so no matter the length of the segment, there's an equal amount of points, which is infinite. That's a little counterintuitive. I was pretty interested or shocked, excited when I saw that, so I wanted to show that to you guys. All right, I'll see you guys in the next video where we develop this notion even further.